Hi all, today I want to discuss some topics about wireless network technologies. IEEE has defined the specification for a wireless local area network, called IEEE 802.11, which covers the physical and data link layers. The standard defines two kinds of services, the basic service set and the extended service set. Basic service set. IEEE 802.11 defines the basic service set as the building block of a wireless local area network. A basic service set is made of stationary or mobile wireless stations and an optional central base station, known as the access point. The basic service set without an access point is a standalone network and cannot send data to other basic service set. It is called an ad hoc architecture. In this architecture, stations can form a network without the need of an access point. They can locate one another and agree to be part of this basic service set. Basic service set with an access point is sometimes referred to as an infrastructure basic infrastructure network. Let's see what is the extended service set. An extended service set is made up of two or more basic service sets with access points. In this case, the basic service sets are connected through a distribution system, which is usually a wired local area network. The distribution system connect the access point is in the basic service set. IEEE 802.11 does not restrict the distribution system. It can be any IEEE local area network, such as Ethernet. That the extended service set uses two types of stations, mobile and stationary. The mobile stations are normal stations inside a basic service set. The stationary stations are access point stations that are part of a wired local area network. IEEE 802.11 defines two MAC sublayers. These are the Distributed Coordination Function DFC and Point Coordination Function PCF. The LLC sublayer and the physical layer. Distributed Coordination Function. One of the two protocols defined by IEEE at the MAC sublayer is called the Distributed Coordination Function. DCF uses CSMAICA as the access method. Wireless LANs cannot implement CSMAFCD for three reasons. For collision detection, a station must be able to send data and receive collision signals at the same time. This can mean costly station and increased bandwidth requirements. Collision may not be detected because of the given station problem. Third one, the distance between stations can be great. Signal fading could prevent a station at one end from hearing a collision at the other end. What is the point coordination function? The point coordination function is an optional access method that can be implemented in an infrastructure network. It is implemented on top of the distributed coordination function, and it is used mostly for time-sensitive transmission. Point coordination function has a centralized contention-free polling access method. The access point performs polling for stations that are capable of being polled. The stations are polled one after another, sending any data they have to the access point. To give priority to PCF over DCF, another set of interframe spaces has been defined. What is the frame format? A frame is a digital data transmission unit in computer networking and telecommunication. In packet-switched systems, a frame is a simple container for a single network packet. In other telecommunication systems, a frame is a repeating structure supporting time division multiplexing. There are three types of frames: management, control, and data. Management frame is used for initial communication between stations and access points. Control frame is used for accessing the channel and acknowledging frames. Data frame used for carrying data and control information. What is the Bluetooth? Bluetooth is a wireless local area network technology designed to connect devices of different functions such as telephones, notebooks, computers, cameras, printers, and so on. A Bluetooth local area network is an ad hoc network, which means that the network is formed spontaneously. Bluetooth architecture defines two types of networks: Piconet and Scatternet. Piconet means a Bluetooth network is called small net. A piconet can have up to 8 stations, one of which is called the primary, the rest are called secondaries. All the secondary stations synchronize their clocks and hopping sequence with the primary. But the piconet can have only one primary station. The communication between the primary and secondary can be one-to-one or one-to-many. Scatternet. Piconets can be combined to form what is called a scatternet. A secondary station is in one piconet can be the primary in another piconet. The station can receive messages from the primary in the first piconet and, acting as a primary, deliver them to secondaries in the second piconet. A station can be a member of two piconets. Bluetooth layers. Bluetooth uses several layers that do not exactly match those of the Internet model. Radio layer. What is the radio layer? The radio layer is roughly equivalent to the physical layer of the Internet model. Bluetooth devices are low power and have a range of 10 meters. What is the baseband layer? The baseband layer is roughly equivalent to the MAC sublayer in LANs. The access method in TDMA. The primary and secondary communicate with each other using time slots. The length of a time slot is exactly the same as the dwell time. This is the Bluetooth architecture. What is the RFID? Radio Frequency Identification. RFID stands for Radio Frequency Identification, which is a technology used to transfer data from one point to another without a physical contact. RFID has three parts: a scanning antenna, a transceiver with a decoder to interpret data, a transponder. Scanning antenna emits radio frequency signals in a short distance. This RF radiation does two main things. First one is provides energy to the transponder to communicate. Second one is, and it makes the scanning antenna and the RFID tag to encode and decode data to maintain the mutual communication. RFID transmission was done in three primary frequency ranges: low frequency, high frequency, ultra high frequency. Low frequency means the general frequency operates in range of 30 kHz to 300 kHz. The primary frequency operates in range of 125 kHz to 134 kHz. High frequency means RFID have a primary frequency range of 13.56 MHz. These are average costed RFIDs with coverage range of 1 cm to 1 meter, widely used in kiosk access control applications and NFCs. One of the main advantages of choosing high-frequency RFIDs over low-frequency RFIDs are they have a large memory capacity. But these high-frequency RFIDs have a low data transmission rate. Ultra-high frequency range of ultra-high frequency are 300 MHz to 3000 MHz. Primary frequency varies in between 433 MHz, 860 MHz to 960 MHz. There are two types of RFID tags called active RFID and passive RFID. Active RFID used to track vehicle, assets, and so on. It has a wide coverage range with large memory capacity and high data transfer rate. Passive RFID coverage range is 25 meter, used in supply chain tracking, asset tracking, and so on. It has high data transmission rates. Main disadvantages are expensive, limited memory capacity, and high interfaces. What is the ZigBee? ZigBee is known as Mesh Network Protocol. ZigBee devices have very low power consumption. It can carry small data packets for a short distance until the data packet reaches the gateway. ZigBee was standard by the IEEE 802.15 standard. It is widely used in sensor networks. ZigBee can be operated with 22.4 GHz ISM. ISM means Industrial, Scientific and Medical Frequency Band. In a ZigBee network mesh, a node can act either as a data source or a repeater. This is the ZigBee architecture. ZigBee system structure consists of three types of devices such as ZigBee coordinator, router and end device. Every ZigBee network must consist of at least one coordinator which acts as the root and bridge of the network. The coordinator is responsible for handling and storing the information while performing receiving and transmitting data operations. The number of routers, coordinators and end devices depends on the type of network such as star, tree and mesh networks. Hotspot. A hotspot is a physical location where people may obtain internet access. Hotspot is an area where is accessibility to a wireless network. Some network devices like laptop and mobile phones have built-in wireless transmitters. If such a device contains these added hardware, then that device can be used as a Wi-Fi hotspot. These personal devices can be converted as an access point to other devices which wants to connect to a network. Hotspot can be used to share the data, files, videos and images over the network. What is the Li-Fi? Li-Fi technology in this era of overcrowded world. Wi-Fi is a new way of wireless communication that uses LED lights to transmit data wirelessly. Wi-Fi technology uses energy of LEDs to transmit data. This technology was proposed by the Professor Gerald Haas at the University of Edinburgh. In Wi-Fi technology, data can be transmitted in the visible, infrared, and ultraviolet spectrum of light. It can work in higher bandwidth. Wi-Fi bulbs comes with a chip that modulates the light gradually for optical data transmission. Photoresistors are used to retrieve the transmitted data from the LED bulbs. Initially, Wi-Fi modules were capable of transmission data at 150 megabytes per second rate. The speed has been increased in later versions. Theoretically, scientists have achieved 10 gigabits per second at a rate which is more faster than 802.11 and Wi-Fi standardization. The main advantage of Wi-Fi is they are more secure and reliable. Many remotely operated underwater vehicles use Wi-Fi to control them instead of wired connection. Wireless sensor network. The wireless sensor network can be defined as a network of devices that defines as a network of devices. Communication the information gathered from a monitored field through wireless link. The data is forwarded through multiple nodes, and with the gateway, the data is connected to other networks. Wireless sensor network consists of base station and number of nodes. These networks are used to monitor physical or environmental conditions like sound, pressure, temperature, and cooperatively pass data through the network to a main location. There are several types of wireless sensor networks: terrestrial wireless sensor networks, underground wireless sensor networks, underwater wireless sensor networks, multimedia wireless sensor networks, as well as mobile wireless sensor networks. There are so many advantages. Network setup can be carried out without fixed infrastructure, as well as implementation pricing is cheap and it avoids plenty of wiring, and it can be accessed by using centralized monitor. So, next we discuss wireless security protocols. As wireless network technologies have evolved, so too have their wireless security protocols for securing them. Get a quick overview of the three wireless local area network security standards, and let's discuss the difference between wired equivalence privacy (WEP), Wi-Fi protected access (WPA), as well as Wi-Fi protected access 2. What is the wired equivalency privacy? Developed in the late 1990s as the first encryption algorithm for the 802.11 standard, WEP was designed with one main goal in mind: to prevent hackers from snooping on wireless data as it was transmitted between lines and access points. From the start, however, WEP lacked the strengths necessary to accomplish this. Let's see. Wi-Fi protected access (WPA). The numerous flaws in WEP revealed the urgent need for an alternative, but the deliberately slow and careful processes required to write a new security specification posed conflict. In response, in 2003, The Wi-Fi Alliance released WPA as an interim standard, while the Institute of Electrical and Electronics Engineers IEEE worked to develop a more advanced long-term replacement for WPA. WPA Wi-Fi Protected Access has decrypt mode for enterprise users and for personal use. The enterprise mode uses four-string authentication with the Extensible Authentication Protocol or EAP. WPA was designed to be backward compatible with WEP to encourage quick, easy adoption. Network security professionals were able to support the new standard on many WEP-based devices with a simple firmware update. This framework, however, also means the security it provided was not as robust as it should be. Wi-Fi Protected Access WPA2 as the successor to WPA. The WPA2 standard was ratified by the IEEE in 2004 as 802.11i. Like its predecessors, WPA2 also offers enterprise and personal mode. Although WPA2 still has vulnerabilities, it is considered the most secure wireless security standard available. MIMO multiple input, multiple output. MIMO is a radio communication technology or RF technology that is being mentioned and used in many new technologies these days. Wi-Fi, long-term evolution, and many other radio, wireless, and RF technologies are using the new MIMO wireless technology to provide increased link capacity and spectral efficiency combined with improved link reliability using that were previously seen as interference path. Even now, there are many MIMO wireless routers on the market, and as their RF technology is becoming more widespread, more MIMO routers and other types of wireless MIMO equipment will be seen. The channel may be affected by fading, and this will impact the signal to noise ratio. In turn, this will impact the error rate, assuming digital data is being transmitted. The principle of diversity is to provide the receiver with multiple versions of the same signal. If these can be made to be affected in different ways by the single path, the probability that they will all be affected at the same time is considerably reduced. Accordingly, diversity helps to stabilize a link and improves performance, reducing error rate. Several different diversity modes are available and provide a number of advantages. Time diversity. Using time diversity, a message may be transmitted at different times. Frequency diversity. This form of diversity uses different frequencies. Space diversity. Space diversity used in the broadest sense of the definition means used as the basis for MIMO. It uses antennas located in different positions to take advantage of the different radio paths that exist in a typical environment. Okay, thank you so much.